questions. Next one, another beautiful question, sir. It is how many 9-digit numbers? How many 9-digit numbers? I require a 9-digit number. I require a 9-digit number that can be formed using the digits. Digits to be used are 1, 2, 3, 4, 5, 6, 7, 8, 9. I need to have a 9-digit number. There are 9 digits that needs to be used. Repetition not allowed. Repetition not allowed. Repetition to be not allowed are prime numbers. How many 9-digit numbers that can be formed using the digits 1 to 9? Repetition not allowed are prime numbers. Since there is no 0, any 1 digit out of 9 can come. 1 is fixed. Repetition not allowed. 8 can come. 7 can come. 6 can come. And so on up to. Last 1 digit is left 1 place. Total there are 9 into 8 into 7 into 6 into 5 into 3 into 2 into 1. Total 9 factorial numbers are there. Total 9 factorial numbers are there. In these 9 factorial numbers, I need to find out how many numbers are prime numbers. I need to find out how many numbers are prime numbers. Listen carefully, sir. Can I say one number will be like this? Now, one number will be like this. Just a little bit of common sense, you will get these answers, sir. One number will be like this. Digits are not repeated. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Totally 9 factorial numbers are there. One number will be in this order. What is the sum of the digits? Sum of the digits. Sum of the digits, if you observe, 8 plus 1, it is 9. 7 plus 2, 9. 6 plus 3, 9. 4 plus 5, 9. These 1 9, these and another 9, these and another 9, these and another 9. 36 plus 9, 45. 45, it is divisible by 3. Yes or no? Sum of the digits should be divisible by 3. So, out of 9 factorial numbers, one number will be of this form. Suppose even if I change the order, are the sum of the digits changing? Even if I change the order of the digits, 9, 8 plus 1, 9, 2 plus 7, 9, 4, 3 plus 6, 9, 4 plus 5, 9, still the sum of the digits is 45. That means all 9 factorial numbers, sum of the digits is 45. 9 factorial numbers, sum of the digits is 45. That means all are divisible by 3. If all are divisible by 3, if all the numbers are divisible by 3, how can it be a prime number? Looks like a difficult question, but if you go 100 feet down, you will get the answer very, very easily. Total 9 factorial numbers are there. 9 digits are there. I want a 9-digit number with all the 9 digits. Repetition not allowed. Leftmost any one out of the 9 digits. 9, 8, 7, 6 and so on up to 1. Totally 9 factorial numbers. One number will be like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Sum of the digits is 45. If the sum of the digits is 45, that means the number is divisible by 3. If it is divisible by 3, how can it be a prime number? How can it be a prime number? How can it be a prime number? Very, very important question. I hope it is clear. Another 18th question. A square minus b square. A square minus b square equivalent to 101. A and b belongs to natural numbers. A and b belongs to natural numbers. A and b belongs to natural numbers. Find the value of a square plus b square. Put a star mark on this. 101 is a prime number. 101 is a prime number. A square minus b square can be written as a plus b into a minus b. Because it's a prime number, it can be written as 1 into p or p into 1. Writing like this, it is mathematical mistake. Don't write like this, because if A and B are natural numbers, sum of two natural numbers will always be greater than their difference. Sum of two natural numbers will always be greater than their difference. Will always be greater than their difference. You cannot simplify further. Why? Because 101 it is a prime number. You cannot simplify further, because 101 it is a prime number. If 101 it is a prime number, if A plus B it is 101, A minus B has to be 1. You cannot decompose further. So if I add it, A plus A, it is 101 plus 1, 102. A will be 51. If A is 51, B will be 50. A square plus B square. Answer is 51 square plus 50 square. 51 square plus 50 square. 2601 plus 2500. Answer is 5101. Answer is 5101. I hope the idea it is clear. A square minus B square is 101. 101 is a prime number. Any prime number can be written as 1 into P or P into 1. I cannot write it as 1 into P. Why? Because A and B are natural numbers. If they are natural numbers, sum of two natural numbers should be greater than their difference. A plus B 101, A minus B 1. 2A is 102. A will be 51. A is 51, B is 50. A square plus B square. 51 square plus 50 square. 51 square plus 50 square. Idea clear? 18th one, very easy question. 18th one. I hope the idea it is clear. All the questions whatever we discussed are based on the basic and a foundation question. 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 7, 6, 5, 4, 3, 2, 1. I hope the idea it is clear. Now see here. Now see. The next questions are the intermediate level questions. Intermediate level questions. See the 19th question. For how many prime numbers P is P square? P is a prime number. Once you understand wherever this kind of questions are there, how to solve, once you get an idea, then you can solve it. P is a prime number. P square plus 3P minus 1. For what prime values of P? P square plus 3P minus 1. It will be a prime number. Suppose P, if I take 2, this will become 2 square plus 3 into 2 minus 1. 2 square is 4. 3 2s are 6. 10 minus 1, 9. 9 is a composite number. P2 not possible. P value 3. If P value is 3, 3 square plus 3 into 3 minus 1. 9 plus 9 minus 1. 18 minus 1, 17. 17 it is a prime number. P value 3 possible. What is the concept that we are going to use? Any prime number greater than 3. Any prime number greater than 3. It is always of the form 6k plus or minus 1. Any prime number greater than 3. It is always of the form 6k plus or minus 1. So any prime number greater than 3. It is plus 6k plus 1 or 6k minus 1. 6k plus 1 or 6k minus 1. After this question, just by looking at the question itself, you can say the answer. So this will become 6k plus 1 whole square plus 3 into 6k plus 1 minus 1. Listen carefully, sir. 6k plus 1 whole square, 36k square plus 12k plus 1 plus 18k plus 3 minus 1. If you observe closely here, divisible by 3, divisible by 3, divisible by 3, divisible by 3. 1 minus 1 cancel. That means all the prime numbers greater than 6k plus 1 if I take, This expression p square plus 3p minus 1, it is getting divisible by 3. If a number is getting divisible by 3, it will become a composite number. If it is 6k minus 1, 6k minus 1 whole square plus 3 into 6k minus 1 minus 1, 6k minus 1 minus 1. These can be written as 36k square minus 12k plus 1 plus 18k minus 3k minus 1. Divisible by 3, divisible by 3, divisible by 3, divisible by 3. 1 minus 1. Even this also is divisible by 3. That means any prime number greater than 3, even if you take 6k plus 1 or 6k minus 1, right hand side is divisible by 3. Right hand side is divisible by 3. See here, sir. Directly you can say, if it is 6k plus 1, anyway it is divisible by 3. 6k plus 1 whole square, 6k whole square divisible by 3. 2 into 6k divisible by 3. 1 minus 1, 0. 6k minus 1 also same thing you can hold. So for how many prime values is this expression a prime number? Only one value, and the value of p is 3. And the value of p is 3. Idea clear? Very, very good question. So wherever the questions contains, find out how many prime values p can take such that an expression is a prime number. Substitute the concept. Every prime number greater than 3, it is of the form 6k plus or minus 1. Now we can do this question very fast. P square plus 15p minus 1. Here it is p. P it is 2. 2 square plus 15 into 2 minus 1. 4 plus 29, 33. 33 it is a prime number. If it is 3, 3 square plus 15 into 3 minus 1. 9 plus 45 minus 1. 53. It is also a prime number. Any prime number greater than 3, either 6k plus 1 or 6k minus 1. 6k plus 1 whole square plus 15 into 6k plus 1 minus 1. 6k minus 1 whole square plus 15 into 6k minus 1 minus 1. Now if you observe, 6k whole square divisible by 3. 2 into 6k divisible by 3. Divisible by 3, divisible by 3. Plus 1 minus 1. It is divisible by 3. 6k whole square divisible. 12k divisible. Plus 1 minus 1 divisible. 15 divisible. Answer is divisible by 3. So any prime number greater than 3, 6k plus 1 or 6k minus 1, it is divisible by 3. How many prime values p can take? Either p can take 2 or 3. 2 square. 4 plus 29, 33, or 9 plus 44, 53. Two values prime can take. Similar question we solved. Now, we will end our first question. Are there any other questions? Now, these 22, 23, 24. Okay. So, till 24 we can complete, sir. What is the largest prime number? Largest prime number whose cube divides 1 factorial into 2 factorial into 3 factorial and so on up to 997 factorial, 998 factorial, 999 factorial. Next is 1000 factorial. Next one is 1001 factorial. 1001 factorial. What is the question that he is asking? What is the largest prime number? Largest means we will come from RHS to LHS because we want the largest prime number. Come from RHS to LHS. Find out the largest prime number whose cube divides that number. It should be a largest number and the cube of the largest prime number should divide this expression. Should divide this expression. 1001. 1001 is 7 into 11 into 13. It is a composite number. Not possible. 1000 is an even number. Not possible. 999. It is an even number. multiple of 3, not possible. Even number, not possible. So 997 factorial, these can be written as 997 into 996 and so on up to 3 into 2 into 1. 997 factorial is 997 into 996 and so on up to 3 into 2 into 1. Now listen carefully, sir. Largest, let us see whether 997, check whether 997 is prime or composite. How to check for a smaller numbers, whether the number is a prime or a composite number? Take the square root of that number, root of 997. 31 square 961. 30 it is less than 1024. 32 square is 1024. Write all the prime numbers. Less than 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. These are all the prime numbers less than 32. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. Now see here. We have to check 997 not divisible by 2. 18 plus 7, no. Unit digit is not 0 or 5. 7 14s are 98, no. Sum of the places, no. 13 7s are 91, 87, no. 17 5s are 85, 147, no. 19 5s are 95, no. 23 4s are 92, 77, no. 29 3s are 87, 127, no. Definitely 997 is a prime number. I am coming from RHS to LHS. Definitely 997, it is a prime number. Can I say 997 factorial? It is 997 into something. What is that something? 996 into 995 into 994 and so on up to 3 into 2 into 1. Here 1 power of 997 is there. 998 factorial. N factorial it is n into n minus 1 factorial. N factorial into n minus 1 factorial. 998 factorial. It is 998 into 997 factorial. 997 factorial. Again one more power of here. Again it contains 1 power of 997. 998 factorial is 998 into 997 factorial. One more power of 997. If it is 999 factorial, 999 into 998 into 997 factorial. Again one more power of 997. Are you with me? That means here 1, 1, 1, 1. So cube again it contains 1, 1. Cube perfectly. It is power 5 of 997. Power 5, a power 5 is always divisible by a cube. Answer is 997. What is the largest prime number? Largest prime number that divides the product of whose cube divides the product of this factorial is 997. 997. Again I am telling it's a very beautiful question, sir. 1 factorial into 2 factorial and so on up to 1000 factorial. I want the largest prime number. 1001 is 7 into 11 into 13. Composite number. 1000 it is an even number. 999 it is a multiple of 3. 998 even. 997 factorial. It is 997 into 996. I wanted to know whether 997 is a prime or composite number. I used the prime or composite logic. I got that 997 is a prime number. In that one power of 997 is there. In this another power of 997 is there. Another power of 997. Anyway, power here 1, 2, 3, power 5. I require cube. Definitely it divides. Answer is 997. Very, very good question. Put a star mark. Another one. We did the similar question. A, B, C, D, E are 5 prime numbers, not necessarily consecutive. A plus B plus C plus A plus B plus C plus D plus E, it is 264. Same question we did it with P1 less than P2 less than P3, A less than B less than C less than D less than E. What is the value of A power 5? Assume all these numbers are odd numbers. If I assume that all these numbers are odd numbers, what will be the logic? Odd plus odd plus odd plus odd plus odd. So this will be the odd plus odd, it is an even number. Odd plus odd, even number. Even plus odd, it is an odd number. But 264, it is an even number. That means all the 5 numbers, it cannot be odd. All the 5 numbers cannot be odd. In a prime number set, there is only one prime number that is possible. So it is given that A less than B less than C less than D less than E. That means A is the smallest prime number. A is the smallest prime number. All the 5 cannot be odd. That means it is not possible. 4 has to be odd. And that means the smallest prime number should be even. A value, it is 2. So 2 power 5. 2 power 5 answer is 32. 2 power 5 answer is 32. 2 power 5 answer is 32. Is the idea clear? A, B, C, D and E are 5 prime numbers, not necessarily consecutive. Sum of these 5 numbers is 264. A less than, B less than, C less than, D less than E. Sum of 5 prime numbers. 5 is an odd number. Odd number of odd numbers sum. Answer will be odd. But the right hand side, it is an even number. So all the 5 cannot be odd. 4 can be odd and 1 is even. A is the smallest number. What is the smallest prime number and even? 2. A is 2. 2 power 5, 32. Another one. What is the number of natural numbers in the range n minus? This is a cat replica question, sir. Cat replica question. Cat replica question. What is the number of natural numbers in the range 2 less than n less than 20? 2 less than n less than 20, such that n minus 1 factorial is not divisible by n minus 1 factorial is not divisible by n minus 1 factorial is not divisible by n. Let me take 2 less than n less than 20. Let me see, is there a pattern? N is 3. 3 minus 1 factorial. 2 factorial is not divisible by 3. 2 factorial is 2. 2 is not divisible by 3. It is possible. N is 4. 4 minus 1. 3 factorial, which is 6. It is not divisible by 4. 6 is not divisible by 4. 4 ones are 4, 4 twos are 8. N is 5. 5 minus 1. 4 factorial, which is 24, which is not divisible by 5. 24 is not divisible. N is 6. 6 minus 1. 5 factorial. 5 factorial is 120. Definitely it is divisible by 6. Definitely it is divisible by 6. That means, what is that you observed? Very, very important key point. N minus 1 factorial is not divisible by n as long as n is a prime number. As long as n is a prime number and n equivalent to 4. As long as n is a prime number. Let me take n value composite number. 8. 8 minus 1, 7 factorial. 7 factorial. 7 factorial is not divisible by 8. 7 factorial is 7 into 6 into 5 into 8. See here, n is 8 if I take. 8 minus 1 is 7 factorial. 7 factorial, is it divisible by 8? Definitely yes. Why? Because 7 factorial is 7 into 6 into 5 into 4. 3 into 2 into 1, divisible by 8. 4 into 2, 8. 8 into any number when divided by 8. So 8 not possible. 3 it is possible. 5 it is possible. Next prime number it will be possible. N minus 1 factorial is not divisible by n only when n is a prime number and n equivalent to 4. What are the prime numbers from 2 to 20? 3, 5, 7, 11, 13, 17, 19. And n equivalent to 4. And n equivalent to 4. Totally how many values? 1, 2, 3, 4, 5, 6, 7. 7 plus 1, 8. 8 values are there. N minus 1 factorial not divisible by n only when n is a prime number and n equivalent to 4. This is based on Wilson's theorem corollary that we will discuss in the next class. N minus 1 factorial not divisible by n. I hope the idea it is clear. Very, very good question. It's a cat replica question, sir. 24th, another good question, sir. Please take time to read the question. Then we will solve it one by one. Question is, each of 3 friends, there are 3 friends, F1, F2 and F3. Okay. Each of 3 friends independently think of a number which is the product of, independently each friend thinks of a number, each friend thinks of a number which is the product of 3 different primes. Okay, think of a number which is the product of 3 different primes. Now see here, 3 different primes. Which of the following could be the product of 3 numbers thought by them if no 2 persons think of the same pair of numbers? If no 2 persons think of the same pair of numbers. See here. Suppose 120 it is there. 120 it is 2 cube into 3 into 5. Each of 3 think of a number which is the product of, which of the following could be the product of? 120 is 2 cube into 3 into 5. 2 cube into 3 into 5. Now see here. It is 2, I think. 2 different primes. I'll tell you why it should be 2. Each of 3 friends independently think of a number which is the product of 2 different primes. 120 can be written as 2 cube into 3 into 5. 144 can be written as 2 power 4 into 3 square. 16 nines are. 12100 can be written as 11 square into 10. 11 square into 10 square, which is 100. 2 more zeros. There is a typing mistake here. 12100. This is 420, which is 7 into 60. 60 is 4 into 3 into 5, which is 7 into 2 into 2 into 3 into 5. 3000 is 3 into 10 cube. 3 into 2 cube into 5 cube. 2 cube into 5 cube. Now read the question, you will get the idea. Each of friends think of a number which is the product of 2 different primes. Suppose if I take 120, 120 is 2 cube into 3 into 5, product of 2 different primes. This is the product of, suppose he thought about a number n1, he thought about a number n2, he thought about a number n3. n1 into n2 into n3, it is there in the answer option. It is there in the answer option. We have to say which answer option fits in to this value. n1 should be written as, n2 should be written as, n3 should be written as a into b, c into d and e into f. What are a, b, c, d and f? They are prime numbers. I hope the question is clear. There are 3 friends. Each one thinks about a number which is the product of 2 different primes. Product of 2 different primes. 2 cube into 3 into 5 Can I write it as 2 into 3? Yes. Can I write this as 2 into 5? 2 into 5. But here it will be only be 2 power 1. It should also be written as a product of 2 primes. So 2 power 7 into something else, it is missing. 120, it is out. I hope you are all there with me. 144. 2 power 4 into 3 square. F1 thinks about a number which is a product of 2 primes. 2 power 1 into 3 power 1. Here 2 power 1 into 3 power 1. Here it will be 2 square. Not possible. Not possible. Anyway, they think different primes, so this case is not possible. 121 into 00. He can think 2 into 11. He can think 5 into 11. Are you all with me? 11 into 2 or 11 into 5. He can think 2 into 5. Each number can be written as product of 2 different prime numbers. All the 3 should be different. 2 11s are 22. 5 11s are 22. 2 into 5, it is 10. 22, 55 and 10. All the 3 are different. So the answer is 12100. Answer is 12100. Each of the 3 friends independently think of a number which is the product of 2 different primes. Which of the following could be the product of 3 numbers? Here it is 3. Which of the following should be the product of 3 numbers if no 2 persons think of same pair of numbers? I hope it is clear. Each one is thinking about a number which is the product of 2 primes. Which is the product of 2 primes. Which is the product of 2 primes. The multiplication should give you which of the following could be the product. That is what I wrote. N1 into N2 into N3 should be there in the answer. So 2 power 4 into 3 square. 2 power 1 into 3. 2 power 1 into 3. 2 square. It should be written as a product of 2 different primes. 144 out. 120. It can also be not written. Similarly, 7 into 2 into 2 into 3. Suppose if I write 7 into 2. This one. Here if I write 2 into 3. Here it will be 5 into something. These are not possible. Similarly, 3000 also it is not possible. Very good question. Only thing is here the question is it is not 2, it is 3. It is not 3, it is 2. Here it is as usual, it is 3. This is one what I wanted to erase. I hope the idea it is clear. Very, very good question which makes you think, right, what could be the answer of